love math, enjoy math, learn with Alice Math.
Hi guys, welcome to Alice Math class. Today we're gonna talk about the miscellaneous transformations, which means we combined the three different types of the transformation together. So far, the transformation of y equals fx we consider include the first one, translation. Compared with the previous function fx, now you see fx plus b, which means we didn't change the x value, but we add b at the end of the function, which means we translate vertically. We change the y coordinate. And then y equals f bracket x minus a. So which means previously here the x coordinate, now we need to change x minus a. So which means we translate it horizontally. If b is the positive number, means move upwards. If b is the negative number, which means move downwards. Similarly, if here a is a positive, which means move to the right side by a unit. If a is negative, which means we moved the graph to the left side. The second transformation is stretch. So the first one, fx, which means we keep the same x coordinate, but we times p in front of fx, which means we change the y value. So he stretch vertically. Compared with the vertical distance, p, if p is greater than 1, which means it's moved further away from the x-axis. If p is between 0 and 1, which means here the stretch will be move closer to the x-axis. And y equals fq times x, which means stretch horizontally. And similarly, it depends on the value of q. If q is greater than 1, and then here we be careful, the scale factor is quite different. The first one, scale factor is p. But for the horizontal case, we find the scale factor is not q. Actually, it's 1 over q. So if we stretch horizontally and then q greater than 1, but 1 over q is less than 1, which means it is compressed. If q is between 0 and 1, so 1 over q is greater than 1, so which means it is more far away from the y-axis. The horizontal distance is becoming bigger. It's becoming longer. All right. So the third transformation is reflection. And we also have two different types of new function. One is y equals negative fx, another one is y equals f negative x. Compared with the two types of function, the first one, we keep the same x coordinate, and then we change the sign of y, which means reflected in x-axis. And then the second one, y equals f negative x, we change the sign of x coordinate and keep the same sign with the y coordinates, so which means reflected in y-axis. And also we have some simple questions just to combine with these three different transformations. So today we'll continue to do some mixed problems and then how to use the three different transformations. Let's have a look. The first question, consider a function f(x) and find the function which result if y equals fx is translated through 4 minus 1, then reflected in the y-axis. So here they write it in the vector form, translated through. The first element means horizontally. And the second element means vertically. So I'm translated through 4 and -1. So previous one is fx, and then we make the translation through 4 minus 1, which means move to right side by 4 units and then go downwards by 1 unit. So according to f, right side, which means x minus 4, and then go down by 1 unit, minus 1. Okay, so this is for the first translation, and then reflected in the y-axis. So reflected in the y-axis means keep y coordinate the same, and then we change the sign of x. Okay, keep the y the same, change the sign of x. So here is x means we need to change to the negative x. So is f negative x minus 4, and then minus 1. Okay, so this is the new function after the two transformations. So y equals f negative x minus 4 minus 1. Okay, now look at the next question. Reflected in the y-axis, then translated through 4 negative 1. Compared with the question A, they just swap, just change the order of the transformation. So the first question, we do the translation first, then reflection. The second question, we do the reflection first and then do the translation. So let's have a look. What's the difference between these two new graphs and new functions as well? So previous one is fx, and then we do the reflection first. So reflected in y-axis, which means keep y the same, and then we change the sign of of x. So now it's f negative x. And then now we do the second transformation is translation. Through 4 negative 1, which means move to the right side by 4 units and then go down by 1 unit. We need to replace x with x minus 4, and then minus 1 at the end. So the new function of the new graph would be f negative x plus 4 minus 1. So we can simplify this function as f negative x plus 4 and then minus 1. So this is the new function. Compared with the answer in question A, they are quite different. If we do the two transformations of the same graph, so the order of the transformation is very important. C translates through -2, 1, then stretched vertically with scale factor a half. So for this question, then we do the translation first. And then negative 2, 1, which means we move to the left side by 2 units. And then go up by 1 unit. So we can write down the new function here. Previous one is fx, and then do the translation. Move to the left side by 2 units, which means fx plus 2, and then go up by 1, means plus 1. So after the translation, the new function is fx plus 2 plus 1. And then continue to do the stretch. So here is a stretch vertically. So stretch vertically, which means we change the y coordinate, but keep the x coordinate. Or it means we times the scale factor in front of the fx, Okay, so which means a half times the whole function. Okay, so the whole function is fx plus 2 and then plus 1. We can simplify this new function as a half times fx plus 2 and then plus a half. Alright? Yeah. So do the translation first, and then based on the new graph, and then we do the stretch vertically, and then with the scale factor a half. This is a new function. Okay, so the question D is similar with the question C, but they just change the order of the transformation. We do the stretch vertically first, and then translation. Okay, so we can write down here. Fx, do the stretch vertically first. So with scale factor a half, which means p equals half, so it's a half fx. And then translation through negative 2, 1. So we do the translation. Move to the left side by 2 units, and then move up by 1 unit. So change the x. Replace x with x plus 2. And then the whole y coordinate should move up by 1 unit, so plus 1. Okay, so this is the new function after these two transformations. So question C and question D, we do the two different transformations, but we just change the order of them. The same translation, the same stretch, but we just change the order of the transformation. So you will find we get the different new functions. So the order of the transformation is very important. Okay, let's move on to the next question. Question 2. Fully describe the transformations which map y equals fx onto. Compared with the previous question, they give us the description of the transformations, but now this question, they give us the final new functions, the form of the function, and then ask us to describe the transformations. So normally, how do we describe? We should look at each function and then think of the 3 different types of transformations: translation and stretch and then reflection. Okay, so question A, y equals f a half times x minus 7. So minus 7 at the end, which means we need to do the translation, move downwards by 7 units. But here inside the bracket is half times x, so which means it's a horizontal stretch. So we should give some descriptions. Horizontal stretch. with scale factor. Just remind you, scale factor is 1 over q. Here q is a half, which means scale factor is 2. And then minus 7 means move downwards by 7 units. The second question is a bit more complicated. Y equals -1 plus 2 times f a quarter bracket x minus 4. So we can split this expression first. For example, the previous one is fx, and we can have a look. So now we can change the fx with, for example, 2fx. And then we can do the 2f 1/4 of x. And then continue as 2f 1/4 x minus 4. And then the last step is 2f 1/4 times x minus 4 minus 1 minus 1. Okay, so for each step, we just give some description. For example, 2 times fx. So 2 times fx means the vertical stretch. And then the scale factor is 2. Scale factor is 2. Okay, so based on the new graph 2fx, and then now we transform to 2 times f 1/4 x. So 1/4 times x means we need to do stretch again, but now the stretch is horizontally. And then we find the scale factor should be 1 over q. Q is 1/4, so now the scale factor is 4. So the first two transformations are related to the stretch. And then now based on the second new graph, and then now transform to the third one, 2 times f 1/4 x minus 4. So compare with 1/4 times x, and here we replace x with x minus 4, which means we do the translation. So here translation is move to the right by 4 units. Okay, so the last step, and then we just take away 1, means go down by 1 unit. Okay, so now look through this question. Do the 2 big transformations. One is stretch. Stretch vertically and horizontally, and then we do the translation, move to the right side, and then move downwards. So we can use first step, second step, the third step, and then the fourth step. Okay, so this is for the question B. A little bit complicated, but it's okay. So question C compared to the question B, quite similar. The little bit different is in front of the fx, here the coefficient is positive, but here the coefficient is negative. So negative, which means if you do the stretch, so the scale factor should be positive. But now we have a negative, which means we do the reflection first. So we can split the function again. So fx will do the reflection first. So now it changed to negative fx. So negative fx means reflected in x-axis because keep the x the same. X didn't change. And then now you can transform the negative fx into negative 4fx, which means we times the scalar 4 in front of negative fx. So which means stretch vertically. And then the scale factor is 4. It's 4. Okay, so negative 4fx, and now compared with the function inside the bracket is f a half x. Here is fx, which means we needed to do the horizontal stretch. So here is stretch horizontally. The scale factor is 1 over q. So here is q equals a half, so 1 over q equals 2. 1 over q equals 2. Alright, so now it's time for us to do the translation because here is a half x. We replace x with x plus 3. With x plus 3. So it's negative 4f a half bracket x plus 3. So which means we do move to the left side by 3 units. And then finally, and then we take away 1. Take away 1, which means move downwards by 1 unit, which is negative 4f a half, and then bracket x plus 3, and then minus 1. So we move downwards by 1 unit. Okay, now you see follow the arrow and we do some steps and then finally we go to the new function. So the first step is reflected the graph of fx in the x-axis and then stretch vertically with scale factor 4 and then stretch horizontally with scale factor 2 and then finally we do the translation. We can move to the left side by 3 units and then move down by 1 unit. Okay, so this is the whole procedure of today's tutorial. If you are interested in any other topics you want me to explain, and you can leave it in the comments section below. Keep on learning and I will see you all next time. Don't forget to like and subscribe. Bye.